For jumpers, I recommend using some of our 0 ohm jumper wire, also known as bus wire. I have used Cat 5 wire in the past, which works great due to its thin insulation and the wire gauge is just right. For short jumpers, you can even use clipped lead wires from your resistors. This does, however, require that you solder your resistors on first. The order in which you solder the parts on doesn't really matter, since there's not an exact way for assembling it. For longer jumpers, you'll need something longer than the leads. I like using a pair of needle nose pliers to bend the ends of the wire, however this is for cosmetic reasons and isn't necessary. You might want to mark your holes so you don't place it in the wrong place. I was off one row in one kit that I built, and it took me a long time to finally spot my mistake when the pedal didn't work. It's always better to get it right to begin with than to have to find it later. Some layouts have double links, where 2 jumpers will need to be inserted and soldered into the same hole. The layout should say how they are indicated, so pay close attention for those. Now that I have my first jumpers on the strip board, I'm ready to solder them. I'm using a helping hands holder to hold my strip board while I solder. If you don't have a helping hands holder, I recommend getting one. I've built layouts without them, but these make the task of soldering components to the strip board much easier. You will have to ignore the solder spots on the bottom of my strip board. I made a few mistakes and had to undo them, so there's leftover solder from that. When soldering your kit, I suggest a temperature of about 300 degrees Fahrenheit for soldering. As you solder each joint, apply heat to it only for a few seconds, usually about 3 to 4 seconds. Keeping heat on certain components too long will damage them. I have to admit, I should have used a different tip and smaller diameter solder wire, which you'll see the reasons why later on. I recommend using some side cutters to clip away the extra leads as you go so they do not get in the way of soldering other components. Just as a quick demonstration, I'm going to go ahead and solder one of the resistors on the strip board so I can show you how to use one of the lead wires from the resistor as a jumper wire. I insert the resistor so it's flush with the board, then I bend the lead out just a little, enough to add tension and hold the resistor against the board while I solder it. After soldering it, I go ahead and clip the leads. Be careful not to burn yourself because the leads are very hot after soldering them. Now that I have a wire lead, I'm going to bend it, then install it the same as I would any other jumpers. After I solder the jumper wires, I usually like to go ahead and solder on any sockets the layout has. This is one of the ways the helping hands holder comes in real handy. The IC socket will not stay in by itself, so you have to hold it in place until you can tack at least one pin in place with solder. I use one of the clips on the helping hands holder to push against the socket so that it stays in place while I tack 1 or 2 of the pins. I don't recommend soldering all of the pins just yet, because the socket might not be flush with the board. With only 1 or 2 pins tacked in place, it's easy to adjust if necessary. As you can see, my socket isn't flush, so I'll use my soldering iron to melt the solder while pressing the socket against the board with my finger, and it'll become flush. Be careful not to touch the pin on the socket that you are soldering because it will burn your finger. With the socket now flush with the board, I can finish soldering the rest of the pins. The 2 soldered pins will hold them in place while I solder the rest. If you look at my solder joints, you'll see that I've created a bridge between 2 of the pins. This is why I said I should have used a tip better suited for this type of soldering and a smaller diameter solder wire. This will have to be corrected before I go any further. If your layout has transistors, then it's a good idea to use female headers as sockets for them instead of soldering them directly to the strip board. It's easy to damage some transistors with heat, so this helps prevent that. This also allows you to easily swap the transistors if you want to experiment. The female headers install basically the same way as the IC sockets do. I use one of the clips on the helping hands holder to hold it in place while I tack one of the pins. You will need to tack one of the pins to the strip board by soldering it, then check if it's flush. If it isn't, carefully adjust it while applying heat with your soldering iron to the tacked pin. Once it's flush and in place, finish soldering the rest of the pins. Soldering resistors are just about one of the easiest components to solder onto a strip board. They are non-polarized, which means it doesn't matter which direction you install them. In other words, you cannot install them backwards. Make sure you install them in the correct place according to the layout. Bend the leads so that they will fit into the holes the resistor should go in. Insert the resistor and bend the leads to add tension if necessary. Flip the board over, solder the wire leads, and then clip them. Keep repeating this cycle until all the resistors are installed. Resistors are very durable, so you're not very likely to damage these with heat. On some layouts, you will see one or more resistors that look scrunched up. When you try inserting the resistor, it will not lay flat on the strip board. This is normal. It doesn't matter which way the standing lead is facing, but I normally try to make sure it isn't close to any component that could cause a short, such as an electrolytic capacitor. Next in the build process are the ceramic disc capacitors. These are the little clay-looking round thingies. Installing them is pretty straightforward. I might caution you not to get too carried away with bending the leads because you can damage the ceramic coating if you do. As far as their height from the strip board goes, I try to keep them pretty close to the strip board. You want to make sure you have clearance between the components and the enclosure, so keeping everything as low profile as possible is a good idea. They are non-polarized like the resistors, so you can install them in either direction. Next up in the build process are the polybox capacitors. These are the same thing as the polyester film capacitors, but have a nice box-shaped shell and a set lead spacing. Soldering these can be a little tricky because most of the polybox capacitors we use have short leads. Again, this is where the helping hands holders come in very handy. I use the extra clip to press against the polybox capacitor so I can get the leads tacked with solder, then straighten it if necessary, and finish soldering the pins. Probably one of the most important things to understand about these is the lead spacing. Most of the polybox capacitors that come in our kits have either a 2.54mm lead spacing or a 5mm lead spacing. 2.54mm lead spacing is the distance between two holes right next to each other on the strip board. 5mm lead spacing, technically it would be 5.08mm, but no one refers to it that way, would be the distance between two holes with one hole in between. In the parts list of the kits, I list these before the polyester film capacitors to encourage people to install these first. They will only fit in a specific place, and often there's the same value capacitor in the layout requiring a polyester film capacitor due to the larger spacing between the leads. As far as the layout is concerned, the places for the polybox capacitors are not marked any differently than the polyester film ones are. This is because they are essentially the same, and either type would work just the same. These are non-polarized, so it doesn't matter which direction you install them in, just as long as they're in the correct holes. The polyester film capacitors have a plastic-looking coating on them and have longer leads. As I stated previously, they are essentially the same as the polybox capacitors, but they can fit in a larger variety of places due to the longer leads. They're usually either maroon or yellow in color. They are non-polarized, so again, it doesn't matter which direction you install them in. I always recommend soldering these on after the polybox capacitors, because if you solder them in place of a polybox capacitor and cut the leads, you may end up cutting them too short and then they won't fit where they're supposed to fit. By putting the polybox capacitors on first, you will usually eliminate the chance of that happening. The electrolytic capacitors are the can-looking capacitors. These are polarized, so you must make sure to install them in the correct direction, otherwise things could get nasty. Worst case scenario, they could explode and even catch fire. The negative lead is indicated by the black stripe on the capacitor. In the layout, it's usually indicated by the lighter colored marking. In the layout I'm using in this tutorial, one of the 10 microfarad capacitors is really close to the second IC, and due to its diameter, it must be positioned over the resistor leads just a little bit. This happens sometimes, and it's important to make sure that the leads do not touch. A dab of hot glue isn't a bad idea to help make sure they do not touch in situations like this one. A quick note, the voltage rating is very important on these. The voltage rating on these capacitors is usually what will limit your maximum voltage, so do not apply more voltage to the circuit than what the lowest rated capacitor can handle without first checking to make sure it's safe to do so. Okay, that's as far as we're going to go with the onboard part. We'll come back and install the IC chip in a little bit, and there's a reason I'm leaving that off, and you'll see soon enough. And the next part of this tutorial series, we're going to go ahead and get into the off-board wiring.